Every time we look into the night sky, we see a universe filled with extraordinary wonders. Billions of stars illuminate the darkness. Countless galaxies drift through the endless ocean of space. And enormous clouds of gas continue giving birth to new suns. Everywhere we look, the cosmos appears alive, constantly changing and evolving. It is difficult to imagine the universe in any other state. Yet every great scientific discovery begins with a simple question. What if, one day, all of this disappeared? Every star, every galaxy, every planet, every atom. Even the last photon of light that has been traveling through space for billions of years. If absolutely everything vanished, what would remain? At first, the answer seems obvious. Nothing. An endless darkness stretching forever in every direction. A silent universe without stars, without matter, without light, and without anything left to happen. For centuries, this seemed to be the only possible answer. If everything is removed, only emptiness should remain. But history has repeatedly shown that the universe rarely behaves the way our intuition expects. There was a time when atoms were only theoretical ideas. Black holes existed only inside equations. Even the thought that space itself could bend sounded unbelievable. Today, each of these ideas has become part of modern science. Perhaps emptiness belongs on that same list. What if the greatest mystery of the universe is hidden not inside the stars, but inside the darkness between them? What if true emptiness has never actually existed? It sounds impossible, yet modern physics suggests that this question deserves a closer look. To understand why, we first need to answer a surprisingly simple question. What does it actually mean for space to be empty? At first, the answer appears obvious. Remove every object from the universe and the problem seems solved. But as science explored reality more deeply, that simple picture slowly began to disappear. Our everyday experience teaches us that emptiness means the absence of something. An empty room contains no furniture. An empty bottle contains no water. Following the same logic, an empty universe should contain absolutely nothing. It feels like the only reasonable conclusion. Yet nature has an extraordinary habit of challenging what feels obvious. Again and again, the closer scientists looked at reality, the stranger it became. And perhaps no concept illustrates this better than empty space itself. According to modern physics, even if every galaxy disappeared, every star burned out, every atom vanished, and every photon ceased to exist, space itself would not become truly empty. Something would still remain. Invisible, impossible to see directly, yet undeniably real. For centuries, space was imagined as an empty stage, where the events of the universe simply took place. Stars moved through it. Galaxies expanded inside it. Light crossed unimaginable distances within it. Space itself seemed completely passive. Today, physicists see it very differently. Quantum theory suggests that empty space possesses its own physical properties. It is not merely the absence of matter. Even in the deepest vacuum possible, invisible quantum fields continue to exist throughout the universe. They cannot be seen directly, yet they form one of the foundations of modern physics. These fields are never perfectly still. Tiny fluctuations of energy constantly appear throughout space. They exist for incredibly short moments, yet they never completely disappear. Beneath what appears to be absolute silence, reality remains surprisingly active. One consequence of these fluctuations is the brief appearance of what physicists call virtual particles. They emerge, exist for an instant, and disappear almost immediately. Although they cannot be observed like ordinary particles, their effects have been measured in numerous experiments. This is where our intuition begins to fail completely. These particles are not appearing from absolute nothingness. Instead, they emerge from the quantum vacuum itself, a state that is far more complex than the word empty suggests. In everyday language, a vacuum usually means complete emptiness. In physics, however, it means something very different. It describes the lowest possible energy state of space, but not the complete absence of reality. That distinction changes everything. Once we understand this difference, the original question begins to change. We are no longer asking whether stars or galaxies will disappear. Instead, we begin asking whether reality itself can ever become absolutely nothing. Surprisingly, modern physics has never found convincing evidence that such a state is even possible. Every time science peeled away another layer of reality, something unexpected was waiting underneath. Absolute emptiness always seemed just beyond reach. Perhaps this is one of the greatest lessons the universe has ever taught us. The deeper we explore reality, the more mysterious it becomes. Every answer leads to another question, and every discovery reveals another horizon waiting to be explored. But perhaps the most interesting part of this story lies not in the present universe, but in its unimaginably distant future. After all, stars are not eternal. Galaxies continue moving farther apart, and the cosmos itself is constantly changing. Could there come a time when everything finally disappears? According to modern cosmology, the universe has been expanding for nearly 13.8 billion years. Even more remarkably, this expansion is accelerating. As billions and trillions of years pass, galaxies will drift so far apart that many of them will forever disappear beyond each other's observable horizon. Eventually, the era of stars will come to an end. The giant clouds of gas that once gave birth to countless suns will gradually disappear. Existing stars will consume the last of their nuclear fuel, leaving behind white dwarfs, neutron stars, or black holes. The brilliant night sky we know today will slowly fade into darkness. Trillions of years from now, the universe will be a very different place. New stars will almost never form. Most galaxies will become dark and silent. Space will continue expanding while becoming colder, emptier, and increasingly lonely. For a long time, scientists believed that black holes might become the final surviving objects in the cosmos. Their gravity is so intense that even light cannot escape once it crosses the event horizon. They appeared almost eternal, but nature surprised us once again. In the 1970s, Stephen Hawking showed that black holes slowly lose energy through a process now known as Hawking radiation. The process is unimaginably slow, but given enough time, even the largest black hole will eventually disappear. One day, the final black hole may evaporate completely. At that moment, the universe will appear emptier than ever before. No stars, no galaxies filled with light, no black holes hidden in the darkness. Nearly every familiar object will have vanished forever. If absolute emptiness could ever exist, this seems like the moment when it should finally appear. Yet modern physics still suggests something very different. Even after the last black hole disappears, space itself remains. And as long as space exists, the quantum vacuum remains as well. Invisible quantum fields would continue filling the cosmos. Tiny fluctuations of energy would continue appearing and disappearing. Reality would become unimaginably quiet and unimaginably cold, but not completely empty. The universe would still possess structure, even if almost everything we recognize had disappeared. This completely changes the way we imagine the future of the cosmos. Instead of ending in absolute nothingness, the universe may slowly approach a state that appears empty while still containing the invisible foundations of reality itself. And this naturally leads to another extraordinary question. If true emptiness never appears in the future, did it ever exist in the past? Was the universe really born from absolute nothing, or has reality always existed in one form or another? Today, science cannot answer that question with complete certainty. Modern cosmology offers several fascinating models describing the earliest moments of the universe, yet none of them can confidently tell us whether absolute nothingness ever truly existed. Perhaps this uncertainty is not a weakness of science, but one of its greatest strengths. Science does not pretend to know what has not yet been discovered. Instead, it continues asking better questions, allowing every generation to explore a little farther than the one before. History reminds us that many of humanity's greatest discoveries once sounded impossible. Invisible atoms became real. Black holes escaped mathematical equations and entered astronomical observations. Gravitational waves, predicted a century earlier, were finally detected. Again and again, reality proved to be more remarkable than our imagination. Maybe one day we will understand the true nature of empty space. Perhaps we will discover what happened before the earliest moments of the universe, or whether such a question even has meaning. But today, we simply do not know. The more we learn about the universe, the more we realize how much remains hidden beyond our current understanding. Every discovery answers one question while quietly creating several new ones. The horizon of knowledge continues moving farther away. Perhaps the greatest mystery of the universe is not hidden inside distant galaxies or black holes. Perhaps it surrounds us every moment, existing silently in the empty spaces between every star, every planet, and every atom. Because sometimes the greatest discoveries are not waiting at the edge of the observable universe. Sometimes they are hidden inside the simplest questions we have never stopped asking.